Hello. All right, well, we're going to record this. We're going to get started. It's 2:34. Welcome. Good to see you. We're going to talk about equation of a circle. We're going to talk, Hunter, we'll talk a little bit about the parabola of a circle. Equation of a parabola. Hopefully I can explain it a little bit for you, okay? But before we do that, do you guys have a dog? Haley, what kind of dog do you got?
I have 4. I don't know. They're all different kinds.
You have a golden retriever?
No.
Hunter, do you guys have a dog? Hunter. I don't know if he's here or not. Looks like he froze. Anyways, I want to show you this because this made me laugh. Can you see it, Haley?
Yeah. You have to start it over. Oh, okay.
Look. Oh, that made me laugh. That dog would not move. That's a golden retriever for you. So, okay, so let's see here. Share screen. And let's get rid of that. Okay, so now let me connect this. All right. Can you see that? The equation of a circle. Hey, before we get going, let me make sure Hunter didn't make it back in here. All right, I don't see him, but okay, so here's the equation of a circle. It's not found on page 890. It's kind of different. I don't know if you guys watched the video or not, but if you guys remember the distance formula, how we have the opposite sign here, this is actually a positive at h, and this is a positive k. And hk is the center of the circle. And then r, of course, is the radius. And so the first example says the center is at 4, 3, and the radius is 4. So if I have a graph, and I know that the center is positive 4, that means I go to the right 4, 1, 2, 3, 4, and I go up 3 because the y values, or the k value is 3. And so that's the center, which is 4, 3. And then the radius is 4, and so I go over 1, 2, 3, 4. That's on the circle. I go up 1, 2, 3, 4. I go over 4, and I go down 4. So you can kind of see the 4 different spots of that. Where's my red one? Oh, there it is over there. Well, if I connect kind of in a circle, there's the, that's an ugly circle, but that's it. It's got a radius of 4. Now, the equation of the circle doesn't ask for that. Oh, there's Hunter. He says he's waiting. The equation of the circle then would be x minus 4, y minus 3, and that's equal to 16. So there's the equation of the circle. Okay? All right, questions on that? Pretty simple. By the way, this should never be asked. When will we ever use this stuff? Welcome back, Hunter. Okay, so let's look at another one. Can you guys still see my screen?
Yeah.
Yeah.
All right, right here. There's number 6. There's the answer. And so if we've got -1, -1, and a radius of the square root of 3. So what that would look like then, since it's a negative, you have to play that game. It's the opposite. So it's x plus 1 squared plus y plus 1 squared. And then you take the square root of 3 and you square it. So this side doesn't, there's nothing to simplify necessarily. You don't like multiply that out. You just leave it in that form. Then you have y plus 1 squared. The square root of 3 squared is actually the square root of 3 times the square root of 3, which is the square root of 9, which is 3. That makes sense? I mean, that's the basic things for, the area of a circle. You're going to have some of that on Monday. We're going to, assign another one of those things that we did this past week, just like that. All right, let's talk about the equation of a parabola and the parts. Let me pull it up first for us in a book. All right, so here's the book. Do you guys have your book at home?
Yeah.
Haley?
Yeah, I do.
Okay. Noni, do you have your book at home? She normally chats. That's what she said. Okay. All right, Noni, got it. Let's see. First thing I want to look at is the terminology. There it is. This diagram right here, guys, is the most important diagram because it gives everything that you need. All right. So, can you follow my mouse? Haley, can you see my mouse?
Yeah.
Okay. So a parabola is a set of all points that are equidistant from a given point called the focus. Okay, so look at my mouse, and I'm going to trace the parabola. Let me move that over just a little bit. Okay, so I'm going to trace the parabola, and all the points, as I trace this parabola, all these points are equidistant from the focus. That's where my pointer is now. And this line down here called the directrix. To me, that's really fascinating. So if I would pick a point like right here where my pointer is, if I measured that from the focus to this point right there, and then from that point down to the directrix, it would be the exact same. It is always the same. So again, it's a set of points that are equidistant from the focus and the directrix. All right, let me make a picture and kind of teach you from the beginning. So if I have a coordinate plane like this, and here's a parabola. Okay, now that parabola is equidistant from that point from that line. Let me get a different color. So this right here is called the focus. That's the name of that point. And then this line is called the directrix. Now, not this year. We probably won't have any questions on a test because we are going to be taking a test, by the way, just as a heads up. We're going to probably do it on Pivot. Okay. It's going to be all multiple choice. It's going to be open book, but it's going to be a time limited thing. So let's say it's 60 questions, but you only have 70 minutes to do it. You know what I mean? So that's how we're going to do it. Anyways. All right. So there won't be any questions on parabola about it other than the assignment on Monday. Okay. So just so you know. But for Algebra 2 and for going forward, the conic sections, that's what this is kind of under that whole label, conic sections. That's pretty important for Algebra 2 and for pre-calc geometry. So it's important that we talk about it, give you an intro. All right, so now look at this. I think this is really fascinating. All right, now I'm going to focus in. Okay. All right, so now we got it. So now look, if I go from the parabola to the focus, and let's just say that that length is 2. Then the length from that point on the parabola to the directrix is also 2. Always. I think that's pretty cool. Watch this. Let's say I pick this point. Any point, anywhere on the focus. I mean, on the parabola, any point. If I go from here to here, and let's say that that's 3. Now, I got to make sure that it's the perpendicular distance because that's the shortest distance. So the distance going down to the directrix, guess what length that is?
3.
3. Always. Okay. All right, so let's do one more. So let's say that we go straight across. And let's say that that's 5. Then we go straight down. That also has to be 5. Okay. Now, with that understanding, then the equation of the parabola, I think, makes more sense, Hunter. Okay, because it kind of explains then. All right, this point is called the vertex, and that's the tip or the apex of the parabola. That's this, and the focus is here.
Mm-hmm.
The directrix is here. And the directrix is always a line, not a curve. And in this case, since it's a horizontal line, it would be y equals. But if we did everything this way, then the directrix would be maybe something like this. And the focus would be about here. Okay? All right. Good. All right, let me go back to the book and then we'll get the equation of a parabola. All right, so perpendicular to the directrix, vertex, parabola shown is at the origin. Okay, and then it says to derive the equation of a parabola. Let's move on down. They use the distance formula. We don't need to get into all that. That's why I didn't have you. That's not part of what I wanted you to take notes on today. All right, so over here, there is the equation. If you see my mouse, there's the equation for the general form of a parabola. 1/4p x squared.
Okay.
Remind students that the equation of a parabola vertex 0, 0 is this. Okay. Now, there's more to it, which we're going to get into. For instance, what if it moves? What if it goes to the left? What if it goes to the right? You know, it's not at the origin. Okay. All right, so watch. All right, now this is a good one right here. Look at letter B. It says write the equation of the parabola with focus 0, -4. That means the focus is way down here. right there where my mouse is. And the directrix then would be 4 units away, would be way up here. Okay, and so the parts of this, the focus parabola is at -4, so that's our p-value. That'd be -4. And then the general equation, you just substitute -4 in for p, and that's where the 16 comes from. Okay. Now the origin is still 0, 0, so you don't change it. So it's still negative, it's still 1/4. The reason it's negative because it opens downward. Okay, and so then to find how wide or how flat the curve is, all depends on when you put it into the equation, what your corresponding x and y values are. And so that's what this box tells us right there. Okay, so since the focus, all right, you got to watch my hands here. You guys see them all right? Since the focus is a long way away, then that's going to make the curve pretty wide. If the focus is really close, then that's going to make the curve really close. Okay, it's honestly, if we look at this, the focus in a case like this would be really close. But down here, the focus would be way further down. It all depends on how flat or how steep the parabola is. Okay, all right, let's move on. All right, so here's a good one. The origin doesn't change. So the origin's still at 0, 0. So you can see in pink, that's what my work would be from the book. It opens downward. Why does it open downward? Because a part of the focus is below, is under the origin, 0, -1. And the directrix then, now how do we know that the directrix is y equals 1? Well, remember, it's the same amount of units away from the origin that the focus is. Let me say that again. It's the same amount of units away from the origin as the focus is. So the focus goes down to -1, and so that means the directrix would go up to +1, 1 unit away. Okay, so they're corresponding. So notice that it's only 1 unit away, so that makes this parabola narrower. So if I trace it, that's a narrower parabola, a steeper parabola than what the last one was. Okay, so now, what if we've got a little bit more work in here, and now the focus is 3, 5. Come on. The focus is 3, 5, and the directrix is y equals 3. All right, let's take a look. So over here, the focus is graphed as f. Can you guys see that right here? Focus is graphed as f. And then where's the directrix? -3, right? See, it's way down here. Okay, now how did they find this vertex? That's what the V represents. How did they find that? What do you think? Taylor, what do you think? Just take a guess. It's okay.
They went down 4 from the
They did,
focus.
but why did they go down 4 and not 5? Or why did they go down 4 and not 3?
Because P equals 4. I don't know.
Okay, let me explain. You're right. Okay, but here's what that represents. The vertex is halfway between the focus and the directrix. So if I were to count, now watch my mouse. Can you see my mouse? If I were to count 1, 2, 3, 4, 5, 6, 7, 8. You see that? So there's 8 units between the focus and the directrix. Does that make sense? That means the vertex is halfway. Why? Because it has to be equidistant. So we know that the parabola goes through this vertex some way, some shape. It might be really flat. It might be really narrow. I don't know yet, but we know that it goes there. Now, another way to look at it, let me bring you over here other than the graph. Look at this. If the focus is at 3, 5, what's the y coordinate? 5. What's the y over here? -3. How far is it from 5 to -3? 8 units. So once again, I take 8 divided by 2, and it says that right here. Find the midpoint of the segment, right here, third point. The segment is 8 units long, so the vertex is 4 units below. Does that make sense? So you can find the vertex by finding the midpoint between the focus and the directrix. I will always give you the vertex. So it's interesting because if you've got 2 of the 3 parts, you can always find the third one. So let's say that I have the vertex and I have the directrix. Can I find the focus? Yeah. Okay, so watch this. So let's say that I know that a directrix is right here. If I know that the vertex of a parabola is right there, then where is the focus? Well, then the focus has to be about here, because I know that it's equidistant to the origin, to the vertex, the origin of the parabola. That makes sense? So if I have 2 parts, I can find the third. So let's say, on another picture, let's say that I know that my parabola looks like this. So here's the vertex, and I know that the focus is here. So where's the directrix? It has to be down here. Because this distance and this distance are the same. That makes sense? Yeah, it's not necessarily easy. And we haven't talked about one really important thing, which you're going to have to look at, and that is when the vertex is not 0, 0. Okay, so I'm almost out of time here. So let me finish this off. So like on this one, the vertex is not 0, 0, right? I mean, it's way over here. And so look at what they have to do for the formula of the parabola. And this, Hunter, might be what you were talking about. So the equation of the parabola in this case is look how that's a little different than what we were looking at before. And this equation, hold on, let me see my mouse circling right here. I wish I could mark on my screen, but I can't. Okay. This mark right here, this equation is for a parabola when the vertex is not at the origin. Do you see the difference? And so it's similar to that of a circle, because how far did we move on the H? We moved +3. So here's the H, moved +3. How far did we move on the K? We moved +5. And then why is the p-value 4? Because that's halfway. That makes sense. This is what I wanted you to do and go through today on your own. But hopefully it makes a little bit more sense now. So you have 2 different equations, one when it's on the origin, one when it's not. Honestly, this equation right here, this will work every time. You just have to put 0, 0 in. Okay? But again, are we going to be tested over this for a parabola? No, I'm not going to test you on a parabola. No. Is it on the homework for Monday? Yes. It's just because I want to give you a good start on this when it comes for next year. All right. Hunter, does that help?
Yes, it does.
Okay, good. Haley, questions? Noni, any questions? No. The problems on for e-learning for today, those are just to help you get ready for the assignment on Monday. Okay? So like if you took notes on the vocab, which I wanted you to do, you did these problems on your turn, those are just for your own benefit to get you ready for Monday. They're not, you don't need to submit them.
Are these like the thing we did Monday like 2 days ago? Is that like a quiz or is it just a worksheet?
No, I'm counting it as a grade. So I haven't started grading those yet because they were just due last night. But they're going in the grade book, and I think last week was 20 points. I'll probably make this one 20 points too. There are 18 questions.
Okay.
But yes, it's going in the grade book.
All right.
Did you guys submit them on Canvas?
Yeah.
Yes.
Okay. I had a hard time, and this is just teacher talk. I had a hard time. It took me a long time to grade them all because when I would pull them up on email, the processor for the computer just took a while for the picture to show. And so like when I would grade yours, I'd have to wait for the picture, the photo. And then some people, their photo, like they did like a selfie, I couldn't see it. And so they had to resubmit and it took a while. So I'm hopeful that the Canvas is a little easier, but we'll see. So I'm going to start grading those today, tomorrow. So, okay.
Yeah.
Everything all right with you guys, your families, healthy, grandparents, anything, everything all right?
Yeah.
Good. All right. Well, it's good to see you guys. And I sure miss school. I kind of like being in my sweatpants and sweatshirt. I'm just saying, it's kind of nice. But I do miss being at school and the routine of it, I eat too much. I'll probably gain weight during this dumb thing. My wife and I call it the quarantine weight gain. So, all righty. Well, it's good to see you guys, and we'll have another one. Well, I don't know if we'll do a Zoom. Yeah, we probably will do a Zoom on Monday, probably afternoon, like we did this week. I'll record this one. This is being recorded, and then I'll post it so you can come back and look at it. Okay?
Okay.
All right, guys. See ya.
See ya.